Query-based stemming. This is a spin on stemming, and this is a very sort of search engine specific thing. The idea here is in a normal indexing pipeline, once you do the stemming, you cannot undo it. Right? Once you've decided that police and policemen are the same thing, you cannot separate them anymore, because in your index they map to a single token, and you can't tease them apart anymore. Sometimes you want to tease them apart, so sometimes you want to match policemen exactly, and you're not happy with matching police. So that's where query-based stemming could be useful. The big idea there is you defer the stemming process until the very end. So instead of stemming the words in the beginning, what you do is you leave the words in their original form. So if the document contained policeman, you would keep policeman there, and if the document contained police, you would keep police. You don't conflate them to the same thing. And then at query time, when the user puts in a query, what you do is you take the words in the query and you expand them up to the appropriate class of words. So if the query contained political, you would do some analysis and say, okay, I want to expand that to match any of the following words: policy, politics, policies, political, and so on. Now, so this works if you can do the expansion process on the fly in the right way. So how can you do that? How do you construct these stem classes? And typically you use statistical techniques for that, techniques that combine some properties of the English language. So you start by taking all the words that you observe in your data, you group them into rough sets based just on the prefix. So, for example, you could say, take a 3-character prefix, and then all the words that begin with pol, P-O-L, would get grouped into one class. So that's all the political police policy things. It's also polar bears and Poland and everything else that begins with a pol. So that, of course, isn't particularly good. But once you have these rough sets, what you can do is you can do further analysis. You can look at the individual words in this set and see how often they co-occur in the same documents. And what you'll see is that the word political occurs in the same types of documents as policy, but it doesn't occur in the same type of documents as polar bears, at least not as consistently. Right. So 2 steps. First you group by prefix, and then you refine those initial classes by pruning them based on how often the words co-occur. And I'll give some metrics for measuring co-occurrence later in this lecture. So it's actually a very effective technique, but it is computationally expensive, right? If you imagine doing it at query time, doing the expansion at query time, you're blowing up your query to be much longer than it is. So you will take a hit in performance at runtime. It's also pretty hard to get it just right. So, by the way, step number 1. It works for English. Would it work for, say, an Eastern European language? No, why not? They use prefixes, that's right. And English has some prefixes, but it's surprisingly averse to them. So most of the time, the beginning of the word in English is actually the root. So you're taking advantage of that step. By the way, you don't actually have to do step 1, right? You could just do step 2. You can take the whole set of words and just do co-occurrence analysis on that. Problem is, whole set of words is pretty big. And this allows you to cut down your search space a little bit in the beginning, right? And it works well for English.